Vector calculus. Vector calculus or vector analysis is a branch of mathematics that has practical applications in physics and engineering. It is concerned with differentiation and integration of vector fields, primarily in three-dimensional Euclidean space. The term vector calculus is sometimes used as a synonym for the broader subject of multivariable calculus, which spans vector calculus as well as partial differentiation and multiple integration. Vector calculus plays an important role in differential geometry and in the study of partial differential equations. It also plays a significant role in various aspects of machine learning, providing the mathematical foundation for understanding optimization algorithms, model training, and feature space analysis. Fundamental concepts. Vector fields. A vector field is a mathematical construction that assigns a vector to each point in a given space. Vector fields can be visualized using vector plots or field lines in a two-dimensional space. For example, each point on the plane is associated with an arrow indicating the direction and magnitude of the vector at that point. Line integrals. A line integral is a mathematical tool used to calculate the total of a scalar or vector field along a curve or path in a vector field. Line integrals are particularly useful for determining quantities such as work done by a force, circulation of a fluid, or flux through a curve. Green's theorem. In vector calculus, Green's theorem relates a line integral around a simple closed curve C to a double integral over the plane region D, bounded by C. It is the two-dimensional special case of Stokes' theorem. It states that let C be a positively oriented, piecewise smooth, simple closed curve in a plane, and let D be the region bounded by C. If L and M are functions of x, y defined on an open region containing D and have continuous partial derivatives there, then where the path of integration along C is anticlockwise. Divergence and curl. Divergence and curl are two measurements of vector fields that are very useful in vector calculus. Both are most easily understood by thinking of the vector field as representing a flow of liquid or gas. That is, each vector in the vector field should be interpreted as a velocity vector. Roughly speaking, divergence measures the tendency of the fluid to collect or disperse at a point, and curl measures the tendency of the fluid to swirl around the point. Divergence is a scalar, that is a single number, while curl itself a vector. The magnitude of the curl measures how much the fluid is swirling. The direction indicates the axis around which it tends to swirl. Surface integrals. In vector calculus, the surface integral is the generalization of multiple integrals to integration over the surface. Sometimes a surface integral can be thought of the double integral. For any given surface, we can integrate over surface either in the scalar field or the vector field. In the scalar field, the function returns the scalar value, and in the vector field, the function returns the vector value. Like the line integrals, the surface integrals are of two types, namely, number one, surface integral of scalar function. These integrals involve integrating a scalar valued function over a surface. Number two, surface integral of vector function. These integrals involve integrating a vector field over a surface. Stokes' theorem, also known as the Kelvin-Stokes theorem, is a theorem in vector calculus. Given a vector field, the theorem relates the integral of the curl of the vector field over some surface to the line integral of the vector field around the boundary of the surface. The classical theorem of Stokes can be stated in one sentence. The line integral of a vector field over a loop is equal to the surface integral of its curl over the enclosed surface.